Welcome back, students. Now I'll be teaching you about the most vital element which we inhale, that is oxygen. So oxygen family I'm going to discuss here, and I'll be teaching you about the various physical and the chemical properties, the oxidation number. Also, this family is known as what? Chalcogens family. Chalcogens family. So here let's proceed for the chapter. Next, students, our topic is oxygen family. So oxygen, which is the most vital element for us, to survive on the planet Earth, is also a part of P-block elements. P-block elements. So this 16 group, it comes, oxygen, sulfur, selenium, tellurium, polonium, and they are known as what? Chalcogens. They are known as chalcogens or ore-forming elements because they are present in most of the ores. Most of the ores in the earth crust. So the first four members, they are all non-metals. One, this is oxygen, then sulfur, selenium and tellurium. And this polonium one is your radioactive metal. Radioactive metallic character. What is general trend? This is general trend. You have 2s2, 2p4, 3s2, 3p4 means s2p4 configuration. Then again here the oxidation state will vary, from -2 to +6. Atomic radius, if I move down, it will increase. Ionization enthalpy will decrease. Electronegativity will also decrease. Same kind of order. If I talk about chemical properties, then your group 16 show a lot of variation in the chemical property because your oxygen and sulfur, they are reactive. But the reactivity series, which if I move down the group, it will decrease. And the oxygen will react with all the elements. Can react with all the elements. If I talk about hydrides, so it forms H2O, H2S, H2SE, H2TE and H2PO. Every element here form the hydrides in this form. If I have to prepare water, then I will prepare it by heating H2 in oxygen. But for other hydrides, it can be obtained by the action of acids on the metal sulfide. Suppose I take this metal sulfide, sodium disulfide. If I pass on with metal, I will get my Na2SO4, plus H2S. So this is my hydride. This is my hydrogen sulfide. You can get it like this. Similarly, here for H2SE also I will get hydrogen selenide. And the common features, important features of hydrides are what? That it is colorless, odorless liquid. Colorless, odorless liquid. And one of the important essential part of living as well as non-living. Other hydrides are also colorless, poisonous. Gases with a pleasant smell. But H2O is not poisonous. And the volatility, it increases from water, means H2O to H2S, and then again it decreases. The low volatility character is due to the formation of intermolecular hydrogen bonding. Again, you have water, so out of oxygen and sulfur, obviously your oxygen is more electronegative. So that's why here the cases of hydrogen bonding will be more, and that's why it is less volatile. But sulfur, it dissociates, into S2 negative and H plus. Balance the equation. And if I talk about the acidity, then these hydrides, they are very weakly acidic in nature. These hydrides are very weakly acidic in nature. And the acidic nature, it will increase obviously from water to H2T. H2S is the weak diprotic acid. And the distance between the central atom and the hydrogen, it increases down the group, which favors in the easy release of hydrogen as proton. So it's like if I take water, if I take H2S, if I take H2SE and H2TE, then out of this, obviously, my acidity order will be what? It will be H2TE will be more acidic, okay, and your H2O, which is having less acidity, means what? It will be very hard for this to release H plus. It will be very hard to release the H plus because of also intermolecular force. Okay, intermolecular hydrogen bonding also we see. So this is all about the oxygen family. Next we're gonna see about the compounds, okay, of oxygen family. Okay, the important compounds of the oxygen family. Stay tuned. So students, in this part we learn about oxygen physical and chemical properties. Also we learn about the hydride stability. How does it vary? We saw that with respect to acidity and the physical state, how it was varying. Next part, I'll be telling you about the compounds of oxygen family. Compounds of oxygen family. So obviously in this whole group, sulfur is the most important compound, which forms different mixed compound. That I'll be discussing in the next part. So stay tuned with me for that.